Hey everyone, welcome back to your math class and to lesson number 25. Today we're going to be introducing the concepts of perimeter and area. So the plan for today's lesson is pretty much just that. We're going to talk about perimeter and area and what they are. And then we're going to take some time to try and understand the units of measurement that we use when we're talking about pretty much when we're talking about area. It's important for perimeter too, but the units for perimeter are things we've seen before. We'll talk about units a little bit later on, but we'll start with just understanding what perimeter is, what area is, and then we'll get into the units after that. And then next lesson, we will take a look at different shapes and the kind of quick and easy ways that we can figure out what their perimeter and area are. So let's figure out what these things are as ideas first. So the perimeter of a shape is the total length of the outline of the shape. So I'm just going to like draw a shape on the screen. So if I were to draw, and it doesn't have to be a polygon, so it doesn't have to have straight sides or anything. It's easier if it's got straight sides, but it doesn't have to for this. So if you've got this shape, this squiggle that I've drawn in red on the screen, if you were to cut from like a ball of string or like a ball of yarn, a little bit of string that you could perfectly lay it out over top of the red, loop that I've drawn here on the screen, and then you straighten out that string and you try and measure how much string you needed to perfectly cover that outline. That length is the perimeter of the shape. So um, yeah, so perimeter is basically just how much distance do I have to cover to complete one loop of this shape. So you could think of it as, for instance, a wall or a fence that runs around the outside of the basketball court or the field at the school. Um, or you could think of it as, you're going for a walk and you're going to walk around, a certain part of a park, and you want to do a perfect lap around some park somewhere, and the park's not got a perfect rectangular shape or anything like a football field, but maybe there's some trees and you're just kind of following the road that goes around it, right? So if you had like a map, right, and you've just got a forest that's got like this weird shape to it, and then there's some roads that kind of go right around the outside of that forest, and then you want to ask basically, okay, well, what distance do I have to walk to do one complete lap going right around the outside edge of this forest? So that would be your perimeter, the perimeter of the forest. And you could think of that for anything of like a weird shape. It could be a regular shape, like like a rectangular base, like the school, or like a football field or something, and you just want to walk around the outside of the field. But it could also be something that's a different shape and something that doesn't have straight lines necessarily. But, if it's something pretty big, like on the scale of the size of like a neighborhood, then your perimeter would be the distance that you have to walk to get all the way around it. Um, and then, yeah, the last point, yeah, if you draw a shape and then you were to try to lay out a string that covers the line that you drew, that string's length is the perimeter. I already said that. But yeah, perimeter is not too confusing. So in terms of like the the fence that runs around the outside of a field, the length of that fence, the how much fence that you need to put up around the field, that's your perimeter. So for instance, if we were to look at a full-sized football field, your perimeter of the field is marked by the white lines that run around the very outside edge of the field. So it's a little bit harder to see on this light colored background, but there are these white lines that are on the outside edge of the field. Those lines, if you were to add up the distance, the length of the line from here to here, and then here to here, here to here, and here to here, if you were to if you were to add up the lengths of all four of those lines, you would have the perimeter of the football field. So these arrows don't make perfect sense. So I'm going to do something like that, like that, like this, and like this. So there we go, something like that. So there would be your perimeter of the football field. So um, if obviously if it's a full-size football field, then this length is going to be pretty big, because the full-sized field is pretty large. But for any field, if you were to measure the perimeter of the field at school, and actually, maybe if we cut this lesson a little bit short, if we end up with a few minutes to spare, I would like you guys to think up how you might calculate the perimeter of the football field and the basketball court at the school. So you can think about how you might be able to measure those kinds of distances. And then I want to see if you can measure the perimeter of the football field. So basically, you go out to the field, and I just want you to figure out a way to add up, or firstly to measure how wide the field is and how long the field is. And then you just have to add up, kind of just walking around the field. You measure from here to here, write that number down, here to here, write that number down, here to here, write that number down, and here to here, write that number down, and then add up those four numbers. And that'll give you the perimeter of the football field. So if you guys have something like a tape measure, you might be able to use that. But if not, then you might have to get a little bit creative. Um, but yeah, that can be an exercise for a little bit later today, if we have time. Now let's get into area. Area is a bit weird. So with perimeter, it's just, we're talking about different lengths, right? We're talking about, I want to measure the perimeter of the room that I'm in. Well, that's easy. I just have to measure the distance from the corner to corner of, each of the four corners of my room. If I'm in a perfectly rectangular space, then I just have to say, okay, well, the length from that wall to that wall is this much, and then do the same thing for all four walls, and I'll have the perimeter of my room. And it's going to be in something like, it's going to be measured in whatever we measure other lengths in. So things like centimeters, meters, or if you prefer the imperial system, feet and inches, right? But area is a bit different, and we're going to spend quite a bit of time today focusing on how we measure area and the units that we use. So first things first, what is area? So the area of a shape tells you how much space it takes up on a flat surface. So you could think of this as like, so you could see we'll follow the bullet points on the slide first. So you could have two shapes that look different, but which have the same area. So that means they take up the same amount of space, or you would need to use the same amount of material to create these two shapes. So for instance, I've got this square and this rectangle on the screen, and obviously they look like different shapes. The rectangle is not as tall, but it's also a lot wider. What you'll find is if you were to count up how many like pixels on the screen are blue to make this square, and how many pixels on the screen are blue to make this rectangle, it'll be exactly the same. They take up the same amount of space on the screen. They don't have the same shape, but they have the same amount of space that they take up. So basically the idea with area is if you were to, it tells you, for instance, the way that perimeter tells you how much string you need to outline your shape, the area tells you how much paper you would need to be able to cut this shape out. Yeah, so perimeter tells you the distance around the outside of the shape. So for instance, with this rectangle, your perimeter would be adding up this length here across the bottom, this length here across the other side, and this length here across the top. And you measure those four, and then you add them together. That's your perimeter of your rectangle. The area, though, is concerned with how much space is taken up on the inside. Basically, how much space on the screen is being taken up by this rectangle. That's what the area is concerned with. So if you've ever done any kind of work with something like PowerPoint, maybe you haven't, but if you ever have done any work with something like PowerPoint, then you'll see sometimes you draw a shape like the square or this rectangle, and you'll see little options for how to color it. One of them says shape fill. So what color do you want the whole inside of the shape to be? And then the other one says shape outline. What color do you want the outside of your shape to be? So to bring that back to perimeter and area, the shape fill, the whole inside, that's your area. That's dealing with all this space on the inside, and it's only concerned with that. It doesn't care what shape it is, it just cares how much of it there is. And then the shape outline, that's your perimeter. It's only concerned with the outside of your shape. It doesn't care about how much space it's taking up. So I hope that makes a little bit of sense, but the next slide also has a diagram. So uh, yeah, perimeter versus area. So here's a diagram that kind of explains it. So if you have a rectangle similar to the one that was on the previous slide, your orange outline that you have on this slide here, that would be your perimeter. So if you were to take a ruler, or if this were really, really big, if you were to take a tape measure or something and you measure from here to here, down to here, over there, and back to the start, and you measure those 4 distances with your ruler, then that would be your perimeter. And so this is something that if you guys want, you can pause the video and you can try to measure that out with a ruler and just try and measure the size of this rectangle on the screen. I haven't done it myself, so I can't tell you what the right answer is, but you can try that, just put a ruler up against the screen and don't be gentle with it. Don't draw anything on the screen or anything, but try and figure out roughly how big each side of the rectangle is. Now the area, we're going to get to talking about how we measure area in a sec, but the area again is concerned with the space on the inside of your shape. So to go back to the example of the football field, the perimeter would be the white lines that mark the extreme outermost boundaries of the field, whereas the area is concerned with the entire rest of the field, where all the action happens, all happens within the area of the field, and the perimeter of the field just marks the boundaries, that if you go outside here, you're no longer on the football field. So now we're going to get into talking about units. So perimeter has pretty straightforward units. So perimeter is basically just a special length that's talking about a certain shape, but you're basically just measuring a length or a distance, right? So perimeter is measured just how you would measure any other length or distance. So it's measured in units like centimeters, meters, kilometers, or again, if you prefer the imperial system, something like inches or feet or miles or whatever, right? So this is something that the units of perimeter are not particularly complicated. If any of you have a ruler, typically you will see on your rulers, they've got 2 sets of units on them. So the units, I haven't actually defined what that is. The units are the sort of the most basic like building block pieces of measurement that we use for whatever we're trying to measure. So for instance, for length, we've got things like the meter, the centimeter, and if you have a ruler on you, any of you, then you'll see that most likely on one side of your ruler, you've got centimeters marked out, and it'll say a little cm on it when you're measuring in centimeters, and there should be about 30 of them on your ruler, maybe 30.5, unless you've got a ruler that's half the size, in which case you would have 15 centimeters, but it should be around 30 and a little bit extra on your ruler if you've got the full size ruler that's about yay big. And then on the other side, you've got inches. And you'll see that the tick marks are in different spots for the inches because the inch is bigger than the centimeter, and there are only 12 inches in a foot. So if you've got the full size ruler, it's a foot long, so it's 1 foot, or 12 inches, or just over 30 centimeters. And so yeah, those are 2 different units of length. So you could use both of those when you're measuring perimeter. And if you tried to measure the perimeter of that rectangle on the screen on the previous slide there, then you would have had to be careful to make sure that you're always using the same units when you're measuring. You don't want to use centimeters for one side and then inches for the other side. You'll get the wrong answer, you'll confuse yourself. So you just have to make sure that you're using the same units. And it doesn't always have to be something like this, something on a ruler or a tape measure. If you were talking about, um, for instance, if you're talking about, you want to do a lap of a park, like we were talking about before, um, you could talk about that in terms of meters or kilometers. You could also talk about it in terms of the number of steps you have to take, right? So there's different ways that you could kind of think about it and different ways that you could sort of explain what kind of distance you're covering. So you could say, oh, it takes me 10 minutes, right? That's another way you could do it. It takes me 10 minutes to walk around this thing. It takes me a thousand steps to do a lap of this thing. It takes me, it's whatever, the distance is 2 kilometers or something, right? Um, so there's different ways that you can measure perimeter. Typically, it'll be in units of length like meters or centimeters, but for any of you that uh, might have done this in the past, for me in Canada, it's very, very normal to talk about distances, especially between cities, in terms of time, right? And that's something that within a city you'll also see sometimes that, going from one part of the city to the other, and you ask somebody, oh, how far is it? They might say it's about this distance, like a couple of kilometers. They might say, oh, it's about 10 minutes, it's about a 10-minute walk, right? So that's also explaining a sort of distance, right? So measuring perimeter, nothing too complicated, measured in centimeters, meters, kilometers, inches, feet, miles, units of distance, the kinds of things that you'll see on a football field or, on your ruler, on your tape measure, things like that. Here's where it gets interesting. Now we're going to be talking about the units of area, and area is weird. So we're going to take this slow. The next couple of slides, there's only actually a few slides left in this lesson, but we're going to take things slow. So suppose we have a shape, and for now, we'll say it's something like a rectangle. It's just an easy shape to work with. A rectangle, something like that. Ignore the extra lines. I'm just going to try and get rid of that little corner there. Cool. So we got this rectangle here. And we want to figure out how much space it takes up. So the way area works is we take this space, this rectangle, and we're going to cut up that space into a bunch of little squares that are all the same size as each other. Now, any squares? Like what's the idea behind these squares? So let me explain. So what I'm going to do is I'm going to cut up this rectangle into a bunch of little squares. I'm going to do it something like, going to do a few going across like this. Now, obviously my drawing isn't perfect, but pretend all of these squares are the exact same size. And suppose that if all of these squares are the exact same size, imagine that the side length of one of these squares. So if I were to draw that in another color, in let's say this blue, this side length of the square, suppose that is 1 centimeter. Okay, suppose that's 1 centimeter. Now, if this is a square and this side length is 1 centimeter, then that side is also 1 centimeter, and so is that, and so is that, right? So that's 1 centimeter going all the way around everything here, right? So I could put in all these tick marks going all the way across. Pretend that all of these squares are exactly the same size, so they've all got exactly the same side length of 1 centimeter. Right, now let's count how many squares we actually have in this rectangle. So we got 1 here, we got 2, and then we got 3, 4, we got 5 and 6, we got 7 and 8, we got 9 and 10, 11, 12, 13, and 14. So we've got 14 squares in this big rectangle here. And each square, remember, each little square has a side length of 1 centimeter. So that means that this top side is 1 centimeter, this right side is 1 centimeter, this bottom side is 1 centimeter, and the left side is 1 centimeter, right? So we don't really care too much about the side lengths here, but here's what I want to explain. So normally on a ruler, if you were to measure out 1 centimeter, it's like a little line on your ruler, right? Like if you were to measure out a distance, you're measuring a straight line and you're saying, okay, well, that's 1 centimeter, right? Like the distance between my fingers. If you measure that out, you're going to draw a straight line across and you're going to say, okay, that straight line is 1 centimeter. But this is a square. It's not a line. There's our line that's 1 centimeter long. There's a line that's 1 centimeter long. There's a line that's 1 centimeter long. There's a line that's 1 centimeter long. And together, they're making up a square that takes up some amount of space. So we've got every side is a perfect centimeter, right? Every side of our square here is a perfect centimeter, and it makes a square when you put them together. So what we've decided in math is that the area that's taken up by a square whose side lengths are all 1 centimeter, like the square here, the area of this square is 1 square centimeter. And the way we write that is a cm with a little 2 up there. And that little 2 is actually an exponent. Now, we talked about exponents before, right? Basically, what's happening is we're saying if you take this side length and you multiply it by this side length, that'll give you the area of the square. So if you've got 1 centimeter times 1 centimeter, that's 1 centimeter squared, right, to the power of 2. We talked about that in our exponents unit. And so that's how you get the area of this little teeny tiny square is 1 square centimeter. Now, if you prefer, you could also write that as 1 square, like SQ centimeter, and you'll often see in American units, especially because when the Americans want to talk about feet and inches, they don't always write like FT for feet or IN for inches. A lot of times they do the tick marks. So you can't do the tick marks and then write a number after it. It just looks really weird. So what they'll do is if they want to say square feet, they'll say SQ for square, FT for feet. So that might be something that you'll see if you're ever moving to a new house and you're looking at the size of the different rooms. People will say, oh, what's the square footage? They're asking what's the area of the floor space that you have there. And if it's being measured in feet, then it's going to be square footage. So back to our little square here. So we've got a square with side lengths of 1 centimeter. So the area of the square is 1 square centimeter. Now, that's just the one little square right here, right? That's just this square right there. So if this has an area of 1 square centimeter, but we've got 14 of these squares, well, then that means that this has an area of 1 square centimeter, this has an area of 1 square centimeter, so does this, so does that, and so does every other square in our rectangle here. So if each square has an area of 1 square centimeter, and there's 14 of them, then the area of our whole big rectangle is 14 square centimeters, which again we write as cm with a little 2. So that's 14 square centimeters, and that's the area of this rectangle. And similarly with meters, if you've got a side length of 1 meter and a side length of 1 meter, for your square up here, then your area taken up by that square is 1 square meter. So basically, because we're working with squares, the way it works is you take two perpendicular sides, so not sides that are across from each other, but sides that are touching each other. And if it's a square, they're going to be the same length. But so whatever side length you have for your square, you're going to multiply those two together, and that'll give you your area in the middle. And the units that you're going to use is if you have meters on the outside, you're going to have square meters on the inside. If you've got centimeters on the outside, you're going to have square centimeters on the inside. If you've got feet on the outside, so if I were to, make a square that's like 1 foot by 1 foot, so it's like 1 foot here, 1 foot here, 1 foot here, 1 foot here, then the area of that square would be 1 square foot. So whatever units you're using for the outside of your squares there, the inside will look very similar. You go from centimeters to square centimeters. You go from meters to square meters, feet to square feet, kilometers to square kilometers. So if you've ever gone on like Wikipedia and you've been reading about different countries and their sizes, you'll see, oh, this country has an area of this many million square kilometers. That means that if you take a shape like, I don't know, if you take a country like Canada, for instance, right? You got some shape. This is not my best drawing of Canada, but here's Canada, and you were to take all the land area of Canada and you cut it up into teeny tiny squares where each square is 1 kilometer by 1 kilometer, so 1 kilometer on each side. Then if you were to cut up the entire country into those little squares where every square has a side length of 1 kilometer, then the area of the country will be whatever it is, 10 million square kilometers or whatever, right? So you're just counting up as many little 1 kilometer by 1 kilometer squares that you have across the whole country, and that gives you the size of the country. So we're going to try and explore this again with this rectangle here. So this is a rectangle that's been drawn a little bit better than the one I did on the previous slide. But so what's happening here is we've got a rectangle who's got a side length of 5 meters going across the top and 2 meters down this side. Now for rectangles, we know that this side length and this side length are going to be the same, and this side length and this side length are going to be the same. So the idea behind area is when we're cutting our bigger shapes like this rectangle into little squares so that we can figure out the area, we want the little squares to have a side length of things like 1 square meter, 1 square centimeter, 1 square foot, just one of whatever, right? We want them to have side lengths of 1 meter, 1 centimeter, 1 foot, 1 inch, like easy to work with units. So if we've got this rectangle and it's got an area of 5, or it's got a length across the top of 5 meters, then if I want to cut that up into little squares, I want to separate it into 5 squares that go across so that each square has a side length of 1 meter. So if I do that, then I can do something like maybe right about here, 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 and here. It's not perfect, actually. You know what? We're going to try that again. Something like maybe a little bit more to the left, so something like this, here, here, and here. So now I've cut it up into 5 chunks going across, where each chunk is 1 meter wide, right? And then also going across, it's 2 meters tall, this big box, right? So if I were to cut that going across, then this is also 1 meter, right? So now we've got 10 squares, and for all 10 squares, they've got a side length of 1 meter going around all 4 sides, right? So all 10 of these squares, we've got side lengths of 1 meter. So this is like the diagram that was on the previous slide. You've got a square like so, and if you've got 1 meter on the sides, then your area on the inside is going to be 1 square meter. So we've taken this big rectangle that's 5 meters across the top by 2 meters down the side. We've cut it up into little squares that are all 1 meter by 1 meter on all sides. And there's 10 of those. You can count those out, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those squares. So the area of this rectangle is 10 square meters. All right, so I hope that's making sense. The reason I wanted to spend so much time talking about the units of area is because units are extremely, extremely useful when we're working with things like length, distances, times, duration, weight, mass, right? Things that have some sort of weight to them. And for me, my background is in physics. Units are so, so, so important in physics. And physics is done just doing math, right? All the language of physics is math, but units are so important for you to understand what's going on, what answer you got. So I'll even give you an example of that. If you go back and you measure the perimeter of that teal rectangle with the orange outline from a few slides ago in this lesson, it's one thing, you'll get one answer if you measure it with the centimeter side of your ruler, and you'll get a different answer if you measure it with the inches side of your ruler. So if you were to just write down a number, it's like, oh yeah, the perimeter of that rectangle is 11. 11 what? 11 centimeters? 11 inches? Because 11 inches is not the same thing as 11 centimeters, right? 11 inches, you got to multiply that by 2.5 to get how many centimeters that's going to be. So you're not going to get the same answer at all. So if you just said, oh yeah, I measured it, it came out to be 11. 11 what? You need to write down the units, right? Same thing for if you guys have time to go out and measure the perimeter of the football field. Meters are a little bit more than 3 times longer than feet. So if you were to measure the perimeter of the football field in feet, you're going to get a different answer than if you were to measure it in meters. And this is especially important, not as much in the other units that we've been working on so far in math, but in a unit like geometry, where we're always working with distances and sizes and areas and angles and, lots of measurement going on. It's important that we understand the different little building blocks that we're using for our different measurement systems. So I hope that's been making sense for today's lesson. And of course, as always, please, please, please do not hesitate to let me know if you're not understanding and if you need some extra help, and I can totally figure out a time to host like a review session or something. All right. So last thing, many shapes, a lot of the polygons that we've talked about so far, they've got very useful formulae that we can use to figure out the perimeter and area very quickly, instead of having to take a ruler and kind of measure out each side, which you could do, but you don't have to. And there's easy ways to figure out the perimeter and area of a lot of the shapes that we've seen so far. So we will explore some of those formulae in the next lesson. So that'll be next Tuesday. I'm recording this the Tuesday prior. So on, I don't remember what day it is. It's the 14th or something. So on like the 21st or whatever, roundabout there, we will start looking at how to calculate perimeter and area for a lot of the polygons that we've looked at so far in this unit. So as always, I hope the content of this lesson has made sense. Please do not hesitate to get in touch if you're struggling, if you'd like some more help. Yeah, and if I don't hear from you, then I will see you all in the next video. Have a good one.